Hello, this is Pete Cacciopi. I'm Chief Scientist at Opalytics, and today I'll be giving a brief demonstration on debugging an app that is deployed as a notebook on the Opalytics Cloud Platform. So here we have the Metrorail example that's being implemented as a notebook that's deployed as an app. So to give you some review, if you want to learn about the Miami Metrorail example, you can please read my blog post, which is also based on this blog post by Professor Over at the Beach, Talis Yunus. And if you want to learn about publishing a notebook as an app, you can please watch this video that discusses that with the diet example. So assuming you're up to speed with all those things, here we have a Metrorail data set that's been solved with the Metrorail app. So the app is implemented as a notebook here. So this notebook has been published as an app. And you can see the view status of it here if you wanted to. Right, you can see here it is recognized as an app. And of course, what happens when we run this app is we get this report, which again, I discussed this in the previous blog post. Report has this visualization. This heat map visualization of the total number of trips that you make to the kiosk in order to put money on your ticket, on your fare card for the Miami Metrorail. And as you can see, there's two white squares here, so there's two infeasible subproblems. This matches up with these same two subproblems that Talis found. These white squares down here were just because Talis's blog, he didn't compute all the 120 subproblems. But in fact, all 120 subproblems have a feasible solution except for these two. So that was just a roundabout setup to give you our goal for debugging. So the goal for this is a fairly common debugging or troubleshooting problem you might encounter, where there are some you're experiencing infeasibility and you want to examine that infeasibility more deeply. So how could you perform that if you were trying to troubleshoot this notebook deployed as an app? Of course, so if we jump back here, again, Ample Metrorail app is the name of the notebook. I already have that open in another tab. So all I have to do is connect this input set to Metrorail, which is this is called Metrorail. So here I am connected to that same input set. And now I can just, because my app is a notebook, I can just walk through cell by cell. So let's start doing that, executing cell by cell, where I'm going to be reading from the exact same data that was run here. So I'm executing cell here, cell here. Might as well keep executing. Can execute those non-code cells, those markdown cells. We'll execute the markdown cells as well. Okay, now we've gone through just the setup here of defining the input schema, defining the solution schema, importing the needed modules, importing the needed packages. Now we're getting down into the nitty-gritty. So here we have the DAT, right? We've got the data object. So perhaps you want to jump down here to the scratch section and examine that DAT object a little bit. So what are the table names again? The amount left over. And It's a lot easier to use a notebook, right? Because I just hit tab and it did tab completion. So here's the amount left over table. That looks consistent with the amount left over table that I have here. Okay, so let's jump back up to where we're executing cell by cell. And the asserts are now firing, and they don't give us any problems. Okay, and you might want to examine, okay, what are these full parameters? If you want to examine that, you can. So again, you see how notebooks are sort of self-debugging. It's almost like the debugging is built. It's almost like notebooking, when things are simple like this, when the lines are just executing sequentially, a notebook sort of debugs itself, right? So that's one of the reasons why it's useful to debug a notebook, to deploy a notebook as an app. But as you can see here, now things are going to get a little more squirrely, right? We can't just step through this normally, because if we did, this is all just one big block of code, right? So we can't, if we execute this cell, it's simply going to do everything all at once. And that's not going to fulfill the debugging task of wanting to step through carefully. So what we can do is execute as start debugging and execute this as a debugger. Now, before I do that, I'm going to add a little bit of code here just so that we can have a breakpoint here where there's the infeasible result. So I'm just going to add an else clause to this if statement. And the reason I'm adding that else clause is so I can put this debugging breakpoint here. So now let's step into this for loop using the debugger that's part of the Opalytics Cloud Platform notebooks. So if you're running Jupyter notebooks, if you're accustomed to running Jupyter notebooks, you might wonder, where is this debugging functionality in Jupyter notebooks? For the most part, it doesn't really exist. Now, there are some packages you can go out and get to try to implement debugging functionality in your Jupyter notebook. My experience is they just don't work that well. But, you know, if you mostly, I think people, you know, don't lack the ability to step through their for loops or to step into their subroutines when they're using a Jupyter notebook. But we have that functionality in with the Opalytics notebooks because we created a lot of the Jupyter logic, so we have the programmatic hooks in order to implement our own debugger. So it's all doing the normal things of step over, it works. And now that the mod string has been created, we could evaluate that down here if we want. So this is the string that has the ample mod code. So as you can see, there's a little evaluate window inside the debugger that's running inside the notebook. So we know we're only interested in these two results where it's infeasible. So let's, instead of stepping over, let's just keep running and it will stop at those breakpoints. And so stopped here in infeasibility. It's infeasible. So what are the number of trips and amount left over? So we can query that. Two and 0.25. Does that match up with our expectations? We can look over this graph here. 2 and 0.25. Yep, that's correct. That's one of the infeasible submodels. Now we can execute again and evaluate again. 2 and 1.25, and that's the other infeasible submodel. So I don't think there's really much more I need to do here. You know, I've demonstrated that simply by having your code implemented, having your app implemented as a notebook, you make it more debugger friendly because you can break your code up into distinct cells that can run, where you can control running cell by cell and you can perform evaluations. And then I also demonstrated how we embed a debugger into an Opalytics notebook so that you can carefully debug for loops or programming subroutines. So thanks for your attention, and hope to see you on other Opalytics videos.